Hello everyone, this is Ajay and you are welcome on my YouTube channel, which is Math Cafe. So this one is the part 9 of our topic, which is matrix. So this video is all about orthogonal matrix. So let's see the definition of orthogonal matrix. If let's say A is a square matrix, right? If A is a square matrix and satisfies the condition A multiplied by A transpose is equal to I, or A transpose multiplied by A. So if A transpose multiplied by A or A multiplied by A transpose is equal to I, then we will say that this matrix A is called orthogonal matrix. All right. So let's say if any matrix A is given to us, A11, A12, A13, A21, A22, A23, A31, A32, A33. All right. Okay, so this one is row number 1 and this one is row number 2, this one is row number 3. Let's say all the entries of row number 1, I'll represent it component of V1 vector. Let's say V1 vector is A11 I cap plus A12 J cap plus A13 K cap. All right. Just like that, V2 vector will be all the entries of R2. So component of all the entries of R2 will be V2 vector. So A21 I cap plus A22 J cap plus A23 K cap. Just like that, V3 vector will be if all the entries of R3 is the component of V3. So V3 is A31 I cap plus A32 J cap plus A33 K cap. All right. So we will satisfy this condition for the matrix A. So A into my A transpose is equal to I. So here A into my A transpose is equal to I. So A is given to us A11, A12, A13, A21, A22, A23, A31, A32, A33. All right. If this matrix is multiplied by its transpose, so transpose will be A11, A12, A13, A21, A22, A23, A31, A32, A33. This is transpose of A and that is equal to I. I is identity matrix of same order. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So far so good. So we will multiply both the matrices by row column method. So first row will be A11 multiplied by A11, that is A11 square, plus A12 multiplied by A12, that is A12 square, plus A13 multiplied by A13, that is A13 square. All right. So this is first element of first row. Second element will be, so this row will be multiplied by this column. So here we will get A11, A21 plus A12, A22 plus A13, A23. This is second element, and third element will be A11, A31 plus A12, A32 plus A13, A33. All right, this one is the third element of first row. And let's move to the second row. So this row will be multiplied by column number 1. So we will get A21 multiplied by A11, A22 multiplied by A12 plus A22 multiplied by A12 plus A23 multiplied by A13. All right, this is first element of row number 2. For the second element, we will multiply row number 2 by column number 2. So finally we will get A21 square plus A22 square plus A23 square. All right, and for the third element we will multiply R2 by column number 3. So A21 multiplied by A31 plus A22 multiplied by A32 plus A23 multiplied by A33. Alright, let's move to the third row. So third row will be multiplied by first column, so we will get A31 multiplied by A11 plus A32 multiplied by A12 plus A33 multiplied by A13. This is first element of third row. Second element we will get A31 multiplied by A21 plus A32 multiplied by A22 plus A33 multiplied by A23. And for the last element we will multiply R3 by column number 3. So finally we will get A31 whole square plus A32 whole square plus A33 whole square. Alright, so this is nothing but identity matrix 1 0 0 0 1 0 0 0 1. Hope you understand this. If V1, V2 and V3 are these vectors, so A11 square plus A12 square plus A13 square will be mod of V1 square. Alright, just like that A21 square plus A22 square plus A23 square will be mod of V2 square, and A31 square, A3 square and A33 square will be mod of V3 square. Alright, A11 multiplied by A21, A12 multiplied by A22 and A13 multiplied by A23, this is nothing but V1 vector dot V2 vector, and this is nothing but V1 vector dot V3 vector. So I'll just put all the values here. So finally this one is mod of V1 vector whole square, and this one is V1 vector dot V2 vector, this one is V1 vector dot V3 vector, this one is V2 vector dot V1 vector, and this one is mod of V2 vector square, this one is V2 vector dot V3 vector. Alright, this one is V3 vector dot V1 vector, V3 vector dot V2 vector, and this one is V3 vector square. So this matrix is equal to identity matrix 1 0 0 0 1 0 and 0 0 1. Alright, so we will compare all the corresponding elements. So finally we will get V1 square is equal to 1 is equal to V2 mod square is equal to V3 mod square. Alright, and rest of the elements will be 0. So V1 vector dot V2 vector, V1 vector dot V3 vector, and V2 vector dot V3 vector, this will be equal to 0. So finally we can say that if every component of any row or any column is represented by three vectors, V1 vector, V2 vector, V3 vector, alright, then they are mutually perpendicular and unit vectors. They are mutually V1 V2, V1 V3 and V2 V3, dot product are 0, so they are mutually perpendicular unit vectors. So let's see a note here. Alright, so every component of any row or column are so represented by three vectors V1, V2 and V3. All right, so then they are mutually perpendicular and unit vectors all right, so they are mutually perpendicular to each other and they are unit vectors. Hope you understand this. So let's take a question here. So first question is, if A is orthogonal matrix, then prove that A transpose will be orthogonal matrix. All right, so let's proceed with the solution. So we need to prove if it is actually given that A is a orthogonal matrix. All right, so if A is a orthogonal matrix, that means A transpose multiplied by A is equal to A multiplied by A transpose is equal to identity matrix. All right, so we need to prove that A transpose will also be orthogonal matrix. So let's say A transpose is another matrix B. So we need to prove that A transpose is a orthogonal matrix. That means B transpose B or B dot B transpose is equal to I. That is what we need to prove. So let's proceed. So we will first of all find B transpose multiplied by B. So we will put value of B here. So B is A transpose whole transpose, and B is A transpose. All right. So here A transpose and transpose will be equal to A, and A transpose will be as it is. So it is given in the question that A dot A transpose is I. So finally B transpose multiplied by B will be I. So we can say that B is a orthogonal matrix. Hence B is a orthogonal matrix. B is an orthogonal matrix. All right, so we have proved this. Let's move to the another question here. Prove that identity matrix is always a orthogonal matrix. Alright, so let's proceed with solution. So here we need to prove that identity matrix is always an orthogonal matrix. Alright, okay, so let's proceed. Let's say any matrix B is identity matrix. Okay, and we need to prove that B is a identity matrix. So here we will write B transpose multiplied by B is equal to I. That is what we need to prove. Alright, so let's proceed. B transpose multiplied by B will be nothing but B is I. So I transpose multiplied by I. Alright, I transpose is nothing but I multiplied by I. So that will become I. So here B transpose multiplied by B is I. So we can say that B is a orthogonal matrix. That means I is a orthogonal matrix. So finally we can say that I is an orthogonal matrix. We have proved this part. Alright, so let's move to the another example here. So next question is that if A and B are orthogonal matrix, then AB will also be orthogonal matrix. That is what we need to prove. So let's proceed with solution. So here it is given that A and B are orthogonal matrix. So I can write A transpose multiplied by A, or A multiplied by A transpose is equal to I. That is given to us. Similarly, B transpose multiplied by B and B multiplied by B transpose is equal to I. That is given to us in the question. And what we need to prove? We need to prove that AB is an orthogonal matrix. That means AB transpose multiplied by AB will be an identity matrix. That is what we need to prove. Alright, so let's proceed with the solution. So let's say AB is another matrix. Let's say it is D. Okay, so we will just find D transpose multiplied by D. If this is identity matrix, then it is proved that AB is a orthogonal matrix. Let's proceed. So D is nothing but AB. So AB transpose multiplied by AB. Alright, So we already know that AB transpose is B transpose multiplied by A transpose, and AB is as it is. Alright, so B transpose is as it is, and I'm combining these two terms like this. Okay, so A transpose multiplied by A is I, that is given to us in the question. So B transpose multiplied by I multiplied by B. So if any matrix will be multiplied by identity matrix, then resultant value will be itself. So finally B transpose multiplied by B. That is also given in the question, that B transpose multiplied by B will be identity matrix. So finally we obtained that D transpose multiplied by D is identity matrix. So finally we can say that D is a orthogonal matrix. That means AB is an orthogonal matrix. So I can write here, hence AB is an orthogonal matrix. Hope you understand this. Still, if you have any doubt, please ask me in the comment section. See you soon in the next video. Till then, bye, take care and keep learning.